Good morning, everyone. Welcome to today's webinar, Configuration-Driven PLM Visualization. Today we'll learn how PLM visualization complements Windchill's comprehensive configuration management. For those engineers in the room, you know how critical this is for you, as well as for downstream functions such as quality, testing, manufacturing planning, product service, and even for augmented reality. My name is Liana Henry, and I'm a senior PLM product marketer here at PTC. I will be helping to facilitate today's session. Our presenters today are Robbie Morrison, Senior Product Manager for PLM here at PTC. And our Q&A moderator today is Brad Rood, Windchill Technical Fellow. You've seen Robbie's bio on your console, but I'll let him introduce himself further before he gets started. Here are a few housekeeping items first. Please take the time to look over the tips for a best webcast experience resource to understand how your webcast console works. Before today's webinar, we'll be asking you a few poll questions. You'll have a minute or so to answer, so please participate. And we'll plan to review those answers at the end of the webinar. Throughout the webinar, we will ask new poll questions as well, but we will save those responses until the Q&A segment of the webcast at the end. During today's webinar, we will hold a series of demonstrations. We encourage you to submit questions as they arise into the question queue. We will answer some of these questions in real time and hold some of them until the end to answer during the Q&A segment of the webcast. Today's session will be recorded and will be available on demand following the event. So now I'd like to turn it over to your presenter. Robbie, it's all yours.
Thanks, Liana, and thanks everybody for joining us. So my name is Robbie Morrison. I am the product manager responsible for Creo View, as well as visualization services in Windchill. So today I'll be going over configuration-driven PLM visualization, where we're really focused on the dynamic visualization capabilities in Windchill. So in order to get the webcast started, we're going to start just by welcoming you guys, which we've already done. Thank you for joining us. And then we're going to jump into just a series of poll questions just for our own benefit to understand who and what kind of experience we've got participating in the webcast today. These first 4 questions are really just for us to better understand who's participating and some of the maturity of some of the people who are attending. We're not going to present those. That's more for us on the webcast side. We do have poll questions that we'll pose during the course of the webcast, which we will reveal at the end. So we'll go ahead and get these started while we're waiting on people to trickle in. The first poll question is really just to understand, are the designs and visualization data that you have in PLM today actually matching your physical products, or are there components missing? So this is an important aspect in understanding, especially from an augmented reality perspective. Can you actually display a proper visualization that is accurate to your physical products? Or do your CAD or bill of materials often have certain things missing that are maybe added after the fact? All right, the next question that you should be getting is just to help us understand the ways that you're using PLM visualization today. So we've presented a couple others, or a couple options here that you can multi-select. Everything from just simple thumbnail part recognition down to a more complex digital mock-up process, including interference, cross-section, match properties. We really just want to know all the ways that you're leveraging this data today in your system. All right. The next question we'd like to know is, what are the departments in your organizations which are currently leveraging PLM visualization? Is it just inside the engineering group? Or are you starting to learn to expand that out to groups like quality or manufacturing and service? And the last question we'll ask before we get started with the presentation is, what are the departments that don't currently use this information, but you think would be able to benefit if they could use PLM visualization to understand what they're looking at? All right, so with that, I think we probably will have enough people who joined to the webcast now, and let's go ahead and get started on our primary content. So in the webcast today, we'll be hitting on a couple things. So first of all, what is dynamic visualization? What is it? Why is it important? Why is this an area of focus that we'd be doing a webcast around? The second we'll go over is how does it work, right? It's important in order to understand how to capitalize on this capability to understand what's actually going on underneath the covers. So we'll walk through that a little bit, and hopefully that may explain some of the things you see in your system. The third area we'll go into is just a couple key things you might want to think about when you're considering configuring this, both things about your data as well as where the areas in the system to configure the behavior are. The last thing we'll round out is with a demonstration of some of the more advanced capabilities, where we'll walk through some things that have been introduced in the product, really from about 10.2 M30 up until as recent as 11.2. We'll walk through those, demonstrate them, give you an idea of what they're capable of. Then at the end, we'll round out and we'll answer as much Q&A questions as we can get to in the time that's left. So with that, why don't we go ahead and jump right in and get started. So what is dynamic visualization? Well, like the name alludes to, it is the ability to dynamically build the visualization content or the structure of what you are visualizing based on an existing structure and navigation criteria applied inside of Windchill. So what we mean by this is, if you're visualizing a structure, you have the ability to apply a config spec that will control things like life cycle states, revisions, and also get into more advanced things like options or choices that you might want to apply. We can take advantage of filtering the structure that way and build the visualization content to match it. So this enables some pretty powerful capabilities, like being able to take a look at configured product variants. If you have an overloaded product structure that, maybe engineering produces all the possible options, how do I get an opportunity to look at what one exact configuration might look like? That's what we are able to get out of dynamic visualization. We can also take a look at things more from a time perspective. So if we want to take a look from an effectivity, like a date effectivity or serial effectivity, or even a life cycle state, we can control and see, what does the product look like with all of the release data, and what does the product look like with some of the in-work changes. The other area that this ends up enabling is multi-CAD structures. So for those of you who are working in multiple design tools inside of a single environment or single product, we actually have the ability to assemble those all in space and see what the product looks like, where in the native CAD tools, you may not be able to actually assemble those all together. So where can I get to these capabilities from? So the most prominent one is the visualization tab. So, you see a visualization tab embedded in most of the structure browsers that you're seeing. So everything from the part structure browser or the CAD structure browser that you're probably used to, some of the more advanced ones like the manufacturing associated browser or process planning browser, any of these different structure-based browsers that have a visualization tab are all utilizing dynamic visualization. So they're not loading the static content that's been published. They're actually building this on the fly based on how you built it. So that's the one that most people are used to. The ones that people might not be aware of is if you use a right mouse button from a structure, there's an option to open structure in CreoView. So this allows you to open either the top node or any node that you select and open that structure into CreoView, taking into account all of the config specs that you've applied. The last one that people might not be aware of is actually there in the representations table. If you've enabled that, there's a row called structure that will allow you to open that as well. This will actually allow you to apply a filter from the drop-down before you open that structure. You can even go so far as to create a new representation and create a snapshot of that based on that filter. So if you wanted to create a snapshot of the product when you went into prototyping, and then be able to compare that to what it looks like now, you can actually have both of those persisted as a static representation that you can go back and reference at a later point in time. This gives you a mechanism of kind of snapshotting that, where maybe there's so much changing in the data you want to have this as an item of record. You can actually create that from the representations table. So why are we, what's so important about this? Really, we believe that dynamic visualization is a key differentiator in being able to meet the requirements of increasing product complexity demand. Now most people who are building products are really building family of products or building highly configurable products, where understanding the interoperability of all of those options and capabilities becomes a very difficult task to manage all of the content necessary. So by being able to build this digital mock-up on the fly of this information, it enables a lot of key capabilities like product variant validation through interference detection. Are these things going to fit together? Operation and process planning through NPM links. So, I may want to build up a process plan for assembling some portion of my design, but I want to make sure that that works for everything. Being able to create technical illustration scalability through Creo Illustrate. You can open these dynamic structures in Creo Illustrate, create rich technical illustrations, and be able to keep those up to date as you change the config specs. And the last one, which is a more recent set of capabilities, is using this as a future augmented reality content pipeline. So where better place than PLM to understand and build an exact representation of a physical product that's out there that you're trying to create an experience around than the place that understands how all of that was designed to begin with. You can also help answer key questions from the business. Can we build our product with this set of options? Save time on prototyping and money, right? I mean, rather than having to go and build something just to validate something doesn't fit, create an interference detection of it, validate that it's going to fit ahead of time by configuring that. How do these proposed engineering changes affect me? Maybe we, again, using the analogy of prototyping, I've already started to build something in a prototype, and now I've got a proposed set of engineering changes. How do I really understand what they changed, to me if I'm doing the manufacturing planning, right? Then what better way than to bring them up side by side and look at what the difference is? And the last one, we spoke to it a little bit, is you can also validate products designed in multiple CAD tools where, you may have built up processes in the past reliant on the CAD tool itself being able to open and validate it. But when you're in a kind of splintered design environment, you need an area to bring it all together and validate that it's all working together. So with that, why don't we go ahead and take a look at what some of these capabilities look like in the system for those of you who haven't taken a look at this before. So I'm going to go ahead and open up, and I've got a snowmobile platform here. So this is it's a overloaded product structure here. You probably have seen it before. And if we load this up, I can utilize what's called incremental loading to introduce checkboxes in the structure that I can choose what is and isn't displayed in my screen. So we can see here that it's overloaded. I've got a couple different suspension systems. We can see down here saddlebags, a chair, which obviously won't fit together. We can start by simply manually filtering this. So if I go down here and in this front suspension module, I may want to just select one or the other of the suspensions, and I can do that manually. And then I can go ahead and switch that back if I wanted to, switch to the other, and I can do some manual validation. The other area that we can do here is actually use the save filters to save persisted filters of a particular configured product. So in this case, I may want to look at the bare bones version of this snowmobile. So no frills, no options, just the bare necessities that you sell on a base product. And in this case, it would go ahead and be filtered down to just the front suspension that might be of interest. I can go ahead and I also can create some of those and persist them as representations. So here, we have a bare bones spec that I just drew up, and I can actually save that and open it up at a later point in time. I can also create, maybe another representation of the loaded version of it with every possible option that we may want to see. And I can save that for comparison. So here, when you're opening and you're creating a visualization based on a part structure for an overloaded product design, we have the option to choose a filter. So in this case, I may choose my loaded spec and choose to submit that. Now, that will create a static representation from the dynamic representation. So it will be able to persist this, save it, and then we can reference that at a later point in time. So these are all kind of the base capabilities that we're talking about when we're going through the product, and we're talking through this today. It's really all about using the structure that you're visualizing in Windchill, being able to configure it, and then see what that ends up looking like based on a config spec, based on a filter or set of options. We can actually go and take a look at what that looks like or would look like in real life. All right, so with that, let's go ahead and jump to, all right, so great. This is a great set of capabilities. I can filter and see exactly what my product looks like at any point in time or any set of options. How is this actually working? What do I have to put in terms of work to make sure that my users can take advantage of this? So the first thing that's important to understand is the data involved in this. So the data involved really involves three primary pieces. We've got the part structure, which is here on the left. We've got the CAD structure, which is here on the right. And the key is to understand the relationship between those two. The owner relationship between a CAD document and a part structure transfers the ownership of what we call the representable. The representable is what holds the actual static representation content. So this is where the representation will get vaulted and related to. If there's an owner link between a EPM document and an assembly, it will actually get stored, or I'm sorry, against a part. It will actually get stored against the part, not the EPM document. So in this case, with this top assembly, the top assembly and subassembly will store the representations. But because this part isn't in this bottom CAD model is not in my part structure, it will actually store the representation against the CAD model. So that's kind of key to understanding, how all of this stuff works. And I'm going to apologize. I believe you're seeing my screen there that whole time. So I'm going to switch back to just this diagram here. So this was the data I was discussing just a moment ago. So we had the part structure on the left, the CAD structure on the right, and that's kind of the driving behavior of where the representations are stored against. So how do we utilize these data structures which are stored against the CAD and the part structure in order to build up the actual dynamic visualization that users are seeing when they're looking at a structure in Windchill? So we start by everything coming from CAD, right? That defines the ultimate 3D geometry. I've got a very simple assembly here, really just to demonstrate kind of some nuances of it. We've got, part one, which is just a base plate. Part two is another plate. Subassembly actually, and these are welded together. The reason why I chose this as an example is because welds are an example where the geometry is actually held by the assembly. That has some significance when we're doing dynamic visualization, which is why I chose this very simplistic example. So what that looks like is, we'll just go with the use case of all of these being an owner relationship to the part, which means that the part is going to hold all of the representations, and that's what structure we're going to be trying to look at. If I then look at the representations that are associated to each of these parts, because these are all getting published, each of these parts actually holds its own set of the entire structure. So the top assembly actually contains the assembly itself, but it contains geometry for the subassembly, geometry for the part one and part two. The subassembly then just contains its geometry, et cetera, down to the part level. So how do we go ahead and take advantage of that when we're building a dynamic visualization? The way this works is it will start and go down from whatever structure you're visualizing, and for each individual node, it will determine what version has been applied based on the config spec. go to the representation associated to that version, if there is one. If there's not, it won't. But if there is one, it will then read the very root node in the representation to understand its content. It will also compare, when it does read that representation, it will compare the first level children in that representation to the part structure to understand if there are any differences. So in this case, if the top assembly's representation had an extra child, it would add that into the structure. So as it goes through that, it will then add the top node and any extra children into the structure. It will read from the part structure link where to place the child. It will then go to the next level and read the root node of the representation tied to the subassembly. So in this case, this is where the importance of that weld geometry came in. It's going to have to read the weld geometry from the subassembly's representation. That enters in some restrictions or some constraints in kind of how you visualize this stuff, which is what I'll get into a little bit later in the presentation of things you might want to consider. It then goes on and builds out all of the rest of the content based on those representations. All right, so with that, let's talk a little bit about what some of the things you might want to consider when you're building out this capability for your system. What are the things you're going to configure it? What are some of the best practices and things you want to think about? So the first thing you might want to think about is understanding your modeling practices and publishing strategy. Dynamic visualization is ultimately at the mercy of the geometry being in the desired state somewhere in the system. We can't regenerate like in CAD, so we have to be able to retrieve this geometry from somewhere in the system. That's not so much a concern when you're looking at everything at a latest, but when you take into account history and the fact that we may want to go back and look at a different point in time, that's where your publishing strategy comes in. So let's see where that might create a trouble, right? So in this case, let's have a simple example. That same, it's the same top assembly, subassembly relationship here. I've gone ahead and iterated part 2 up to A.3, so maybe I made it a little bit wider. That's going to change the geometry of the weld, and that's held at the subassembly level, right? So if I have a publishing strategy that my assemblies are only ever published as stored, so that way I can see, what they got checked in with, well, that means the subassembly is going to be publishing this geometry with the A.1 version of that part. That means the weld is actually going to be a different shape than it is in part 2 at its latest version. Then if I go to my top assembly, and maybe higher up in my assemblies, I choose to publish latest. Not sure why, but just hang with me on that. In this case, maybe it was the latest, but I haven't republished it recently. So maybe I actually published it with A.2 of the part. Now, this has introduced a discrepancy here, right? Now, if I go to build this, there's no winning location that I can find the weld geometry for the subassembly. It doesn't exist inside the representation of my subassembly. It even doesn't exist inside the representation of my top assembly. So this is what I mean by, you need to understand your modeling practices. Are you doing things where there's geometries held at assemblies levels or overrides of geometry at assemblies level? And how often are you keeping those up to date to make sure that you can go back and find the right version of the geometry that you need to have? So the next area for consideration that I would encourage you to take a look at is understanding how well aligned your BOM and CAD structures are. So there are working practices where you may have additive things inside of your part structure, or may have things that are coming from your CAD structure that aren't in your part structure. Whenever there's a discrepancy between a CAD structure and a part structure, that's things that you need to understand your business practices in that area, because it can introduce something to consider when configuring the system. So in this case, I have a simple example here where this part 491-20013, it's a wheel. It's actually the center of a wheel. And I like to embed underneath that the semi-finished goods or the unfinished version of the wheel blank, right? So before I drill the holes in the spokes, I embed that as something that gets consumed on the wheel itself. If you have a working practice like this, and this is not necessarily to say that's the right way to go, but it's a working practice, that's a consideration you need to be understanding. Because we're only typically visualizing the children inside of an assembly structure, then it's going to think that the blank version or the unmachined version is the thing to visualize in this case. I'll get into in a moment how you need to tell it not to do that. But this is one of the examples that you need to be careful of. What are your BOM practices where there is a distinct misalignment with the CAD structure and you need to configure something in order to accommodate it? So those are the top two areas I'd say you really need to understand well when you're trying to go after and really take advantage of the configured PLM visualization capabilities in Windchill. Where can I actually do some configuration of these capabilities? So really two areas. There's preference configuration, which is available, all the way down the stack, site, board, context, and users. And then there's also WVS properties, and I'll talk to a little bit into each of the areas that you can configure. So inside the preference configuration, you have the ability to influence whether or not you want to enable incremental loading. This enables the checkboxes in the structure that you saw me demonstrate a moment ago, where I could turn on or turn off things manually at will. The other area that is inside the visualization dynamic structure area in the preference manager, and this allows you to turn on or off certain considerations for them. The top three here are the different features I'm going to go over here in a moment. And that is assembly features and flexible positioning. This is where you override geometry or positioning. CAD represented parts, which is where you actually tell it to load that geometry from a CAD instead of from the part structure. Displaying the representation from image associated content. And again, I'll get into more detail on that in a bit. The last one we're not going to be going over, so I'll spend a second, and that's to controlling whether or not we display unplaced components. So unplaced components are whenever you have something that's been added to the part structure that does not have an occurrence. This would be like my previous example where I added something underneath that wheel level. That would be considered an unplaced component. It didn't come from CAD. Therefore, I may choose not to show that. And that would have been how to address that misalignment, is I would set show unplaced components to no. All right, so the last area for configuration is the WVS properties. What we have in here is a couple key things. Most of them are performance oriented, where we've turned it on for the highest level of performance. But if you have certain scenarios, you may need to turn that off. And really that's the top three here. So the first one is exclude assembly representations. By default now, we actually don't read the assembly representations in order to compare if there's extra geometry that's not in the part structure, unless there's a reason to do so. And a reason to do so would be if we know there's an assembly feature or if we know that there's geometry, we then know to go ahead and read that. But if it's not, then we're not going to compare them and you may have content missing. So if you do have things that are not in your part structure, but you do model in CAD and you need to see that, you may need to turn this off in order to get that to properly visualize. The next there is assembly appearance overrides. Similar to comparing structure, we also have the ability to read the appearance overrides. If you change a color at an assembly level, then we can go ahead and read that and apply it. But by default, we don't do it because it costs performance to go and read that information. And the last one is, again, same theme here, is whether or not you want to read the attributes from the PVS files that were published from static representations and add that into the attributes for opening in CreoView. By default, we don't do that. We only inject the Windchill attributes. But if you do need to have the CAD attributes that came from publishing, you would need to turn that back off to false, which does have a performance cost. The last two here are more around configuring the actual visualization content. load parent for unplaced children is in the content that we have unplaced children that I talked about just a moment ago. If a part has only unplaced children, then by default the system would consider that an assembly and not try and load the geometry. But if it's only children are all unplaced, it means that in CAD's definition this is actually a leaf level part. Therefore, you need to go ahead and load the representation from the part, or the leaf level part in CAD terminology, not the leaf level from the part structure. So this is on by default because that's likely a behavior needed. But if you do need to override that, then you can go ahead and tell it to keep loading them. The last one we'll go into a little further in the presentation, but you can reference the recording here. This is just a mechanism that you can develop a custom hook to control how part structures are loaded. And I'll get into a little more detail there in a second. So with that, we'd like to understand which of the visualization scenarios are you struggling with in your company today. We've listed a couple here. Are all your parts not modeled? Is my bill of material incomplete? Do I have supplier parts and assembly relationships that I struggle to visualize? We'd like to understand where you're struggling today to get accurate visualization. So I'm going to leave this for a couple seconds, let you guys answer that, and then we'll get into the advanced capabilities that have been introduced recently. All right, so with that, we're going to go over the advanced capabilities that you may or may not be aware of. And along the way, I'm going to go ahead and explain these capabilities, demonstrate them, and then we're going to open it up for a poll and see who is aware of that. So it's something that we'd like to understand, how many of you guys are aware of these features or using them already? So the four features that we're going to be talking about today are assembly features and flexible assemblies. This is a situation where an assembly, due to modeling practices, can either change a part's geometry. Maybe it's a deformable part, or maybe it's something that has some machining or holes being cut in it. Or flexible assemblies where an assembly can change the positioning of children or grandchildren based on the context. So maybe these are installable components that based on the installation you have to change where they're located. Both of these are features that are specific for Creo, not specific from a Windchill perspective, but at the moment we're only exposing this for Creo published data. We do have plans to open that up to CATIA V5, NX, SolidWorks in the future, but at the moment these are specific to Creo. CAD represented parts are a scenario where we would like to show, that there's a part in my structure that I know for a fact my part structure doesn't match CAD, and I need to stop using the part structure and use the CAD structure instead. This has been available since 10.2 M30. It's been around a while. It's a really great capability that I think is underutilized to help force alignment and ensure accurate visualization. The last thing we'll talk about is multi-state representable parts. So this is the use case where it requires multiple CAD models to represent a single physical part. And those multiple CAD models use image relationships associated to the WT part in order to show them in the right state. This is something that's been recent. It's been 11.2, and we'll walk through how that works. So let's see what these things take us through, and I'm going to whiz through and let this kind of build itself out here. So this takes us from on the left. We've got everything wrong about this, right? In the yellow, we've got something with flexible positioning where my standoffs for my pump, by default, they're placed together because they need to be arranged based on the pump that's being mounted. I've got my supplier part, so this pump is something that I purchased from a supplier, and I don't model that all in my BOM. I just, I have the full CAD model, but I just use an image association just to associate it to the part, which means by default, the part gets no representation. So, before CAD represented parts, I wasn't able to actually see that pump. We've then got in green here, we got an assembly feature where this coupling fits inside of this base plate. I've got an assembly feature to cut a hole inside of that plate. but without assembly features, it just has, you just see the default part geometry, which is the full plate. And then the last thing is we've got this flexible hose, which, my as designed version of it is a straight piece of hose, but as installed, I have to bend it, right? So I've got a different model that represents the bent version of that hose that I can't visualize correctly because I can't recognize, to load that geometry from the image association instead of the default representation of the parts. So let's get through kind of how that works in the system, right? So assembly features and flexible positioning, as I mentioned, they offer a mechanism where an assembly is overriding either the geometry of its parts or the positioning of its parts. So in this case, the default shape might be, these black boxes, which is just a simple part. But based on where it's installed in my assembly, I may need to cut different lengths of holes, different shapes of holes inside of here. And the assembly is what owns understanding what that resultant geometry looks like. So the way that we handle this is by default, we still continue to build this dynamic visualization structure, but we have a flag that exists in the published representation of the subassembly that contains these features that describes that this subassembly contains a feature that overrides the geometry of the part. So this is why it's important to make sure that you're publishing. If you have these scenarios, this is all tied to publishing. And if you haven't republished it, you may not be seeing that here recently. When we see this flag, we'll still use the position from the database, but we'll load the geometry from the subassembly's representation. And that's how we end up being able to build this out. If it's a positioning thing, then we won't use the positioning from the database. We'll only use the position from the representation, but we'll load the geometry from the child part instead. So it's flexible in that it knows how to do either one of those. So some things to consider here, though. So since we've added assembly features, which has been around since 10.2 M30, we no longer interrogate the assembly representations unless there is one of those flags present saying that there is something in here that needs it. So in this case, I may have this extra part in my top assembly that doesn't show up in my CAD or in my part structure, and because I have, because it doesn't have a assembly feature, it's never going to read this representation in order to find this extra part. If you have situations where you have extra CAD models that aren't in your part structure, you may need to take a look at that WVS property we talked about earlier to tell it to still interrogate the assembly representations. All right, so let's go ahead and take a look at real quickly what that looks like. Running a little tight on time here, but that's okay. I'll speed up a little bit. So now we'll take a look. I've got that same pump representation that we talked about earlier. And we can see here that, I've got these assembly features in this base plate with the part missing. I've also got these standoffs that are not next to each other or not spaced well enough for the pump. So now if I go to my visualization preferences and I navigate down here, we can take a look in this dynamic structure, and we've got an option for each of those. So assembly features here controls geometry. So this is going to control that cutting of the base plate so that way the coupling fits in it. And then flexible assembly features really translates to positioning. It's a little confusing, but this is really understanding the alteration of positioning of children. Each of these has a separate option from part to CAD structures. So keep that in mind. By default, I would say you should probably consider setting all of these to yes. Now, if I take a look at that and go back and load my representation content now, we can see that the position of these children are actually showing up in the right place now. And if I go ahead and I look at this base plate, I do see that there's a nice pretty hole in there. Even though the actual original part geometry, if I go to take a look at that, doesn't actually contain this hole. So if I go back and load this base plate up, we'll see that that's still really this straight piece. All right. So with that, I'm going to jump on forward. So real quick, we'll take a quick poll. how many people were aware of these capabilities in Windchill? Alrighty, I'm going to go ahead and keep going. So the next thing I'll talk about is use cases where I have known differences between my part structure and my CAD structure that I need to be able to understand that, relying on my part structure just isn't going to work. I need to go over and use my assembly structure in order to visualize this correctly. This is what CAD represented parts were built for. And what it does is when there is a CAD represented part, let's say this assembly A, it will, when flagged, use and traverse the image association or the default owner assembly representation, and it will start picking up the rest of the representation structure and processing it as if it was the same inside the part structure. The result is that you get this nice hybrid structure here, where you've actually got a full part structure, but then you've got all the extra content that's coming from the assembly representation. The downfall to this, though, is that wherever you place this, it's going to stop considering the part structure. If there are extra components in the part structure, it will ignore them once you hit a CAD represented part and only use what came from CAD. And I'll go through what that looks like inside of the Windchill system here in just a second. So the other approach to this is the filter method that I mentioned when we were going over the WVS properties. So, CAD represented parts are great, but a lot of people need a lot more flexibility and control over things, right? They may not be able to consistently have a user say, yeah, flag this as a CAD represented part. So that's what this EDR loader part structure filter method was built for. It allows you to write your own Java class where the entire structure will be passed in. You can then use that and tell the system what to do with them. You can either tell it to proceed as normal, which means it'll go through its regular processing. You can exclude that node, which only means to exclude considering the representation. It doesn't mean to not process children. That's a little further down. I'll go there in a second. You can also choose to include the representation and exclude children. This is essentially the same thing as a CAD represented part, where it will then include the representation which would have come from CAD and not process its children. This can be particularly useful for if you're prior to Windchill 11.2 and you're using image association for flexible position or flexible components, so those routed hoses or routed cables, and you need to visualize them correctly. If you set that on its parent assembly level, it will get that from CAD and you'll see the right representation. And the last one here is just exclude the representation and exclude its children. This basically means, just completely ignore this node, right? It may be something additive in the structure that I don't want to care about. So let's take a look at what that looks like in the system. So let's take a look at what CAD represented parts look like. So I've again got my same structure here. I've at least gotten my assembly features looking good. But I've gone ahead and let's go ahead and take a look like what it looks like when I turn on my CAD represented parts. So CAD represented parts do require some configuration. It requires you setting up an XML at the site level, or maybe the context level. Maybe at the org level. That will control the definition of what a CAD represented part is. So this can, this is where you define and give that definition of a CAD represented part a name. I wasn't terribly original. I called it a CAD represented part. But if you have more than one use case, maybe supplier parts, flexible parts that you flag. Now, when they've enabled that, and I go back to this structure, now I can see here, if I load everything up, great, I actually see the entire representation is accurate, which is exactly what I wanted. But it comes with the caveat that you have to be careful. What you can see here from the structure is that when I flag the CAD represented part, which is at this supplier part as well as this assembly that had the flexible component in it that I needed to be careful with, it gathered the representation from, in this case, it traversed an image association to get to on this final this pump assembly. In this case, it went to the default representation, but it stopped considering the parts in the structure. So in this case, I've lost any sensitivity to the content below it. And if I select it from the visualization, all it knows is that all of this content is tied with the assembly. So definitely powerful. I can get my visualization correct, but it comes with a limitation that you lose the sensitivity or a dynamic nature of the content below the CAD represented part level. So that's something to just consider and be careful with when you're doing it. But it is a powerful capability if you're not yet at 11.2. So we'll go ahead and let's see, who in the audience was aware of the methods for loading assembly representations instead of using the part structure, either through CAD represented parts or the structure filter method. All right. So the last thing we'll go ahead and demonstrate is the most recent capability, which is as of Windchill 11.2, which is how to properly visualize image-associated parts. So, enterprise part management best practices encourage, we really want to have all of your CAD models that represent a single physical part to all be associated to one part. You don't want to have extraneous WT parts to represent these things. Like some people call them, dash parts or slave parts. There's a lot of terms for them, but it means that you've got an extraneous WT part that won't show up in ERP. We're only doing it to capture the model correctly. Really, we want image associations to be that mechanism for doing it, but it's been a limitation that we couldn't properly visualize that. Those image-associated representations don't store their content on the WT part, and the dynamic visualization only ever showed the default representation. Now, with as of Windchill 11.2, we have the ability to visualize that correctly. If you're on Windchill 11.2, as part of the build process, so when you check in a part, and it creates when you check in a CAD model and it creates that part structure, it will recognize if any of the children that it built that part structure with came from an image association. In this case, we've got my left and right hand routed version of this hose. This assembly actually contains 3 occurrences of this hose. The straight piece, which is the default representation, the left routed version and the right routed version. But because the assembly contained these other CAD models, it will persist onto the occurrence link, the EPM document master that's associated with those. And what that gets us is we know then when a particular occurrence in the part structure needs to go to a different CAD model to get its representation. We store the master because we still want to use the CAD model that's associated to the right version of the part that's in the structure. So we can go to that version of the part in the structure and identify which version of the CAD document is associated with that version, and the result is that you get the actual right representation. So let's take a look at what that benefit looks like now with this pump model, right? So I'm going to go ahead and share my screen again. And we'll go ahead and I'll go back to my settings here. I am going to turn off my CAD represented part because, again, CAD represented parts was a situation where we didn't have great alignment between my part and my CAD structure. But we didn't have the ability to recognize image associations yet. Now that we do, I can turn that off, turn on the display of image-associated content, go back to that same part structure, go ahead and load it up, and now I see the content correctly, but I also have full association between that content. So I no longer have to have a CAD represented part, even for this use case where this supplier part isn't an owner representation. It actually is an image association only, which is why I don't get the full structure. In both cases, because the top assembly used the CAD model, it persisted on this occurrence link which CAD model I needed to use and gave us that intelligence to visualize it correctly. So this has been, again, a more recent capability, very, very powerful with Windchill 11.2. I think a lot of people get a lot of great benefits. So we're down to 10 minutes, running a little bit long here, but that's okay. We're going to open it up real quick to see who was aware of the recent capabilities in Windchill 11.2 for visualizing image and contributing image associations. Great. All right, so just as a summary, these are a lot of really great capabilities that have all been introduced between assembly features for handling the overrides geometry, that's Windchill 10.2 and 30. Flexible positioning came in with Windchill 11.1 and 10, I believe. CAD represented parts has been around for a while. I think it's underutilized since 10.2 and 30. And then more recently, we have the ability to properly visualize image-associated content. So all of these are all the new technical features that allow us to properly capitalize on a configured PLM visualization capability. It's really important. We want this ability to filter down, see anything based on any configuration, but it requires a lot of underlying components to be correctly enabled to really get that full-scale flexibility of visualizing the content. So with that, let's take a look and see who was aware of some of these capabilities as we did these polls. So visualizing assembly features and flexible positioning, we do have some people who were aware of them. It looks like a lot of people weren't. I'm glad that we were able to share that with you today. Hopefully, you go back and take a look at enabling that in your system and taking advantage of it. Looks like very few people were aware of the capabilities for both CAD represented parts and the structure filter method. Some people were not aware of them at all, and again, I hope that you're able to go and take a look at that with your business and understand, especially CAD represented parts, since it's not that complex to configure, whether or not that makes sense. And then some were only aware of one or the other. So I'm glad that you guys were able to take away some from this and can learn from that. And the last, it looks like we did at least a little bit better job touting the new capabilities in Windchill 11.2, a little bit better awareness of that, but still a lot of people weren't. So I'm really glad we were able to share this with you today. I'm really hoping that you can look at some of the base enablers for really taking advantage of configured visualization in Windchill. So with that, I'm going to open it up for Brad. We're running a little tight. We've only got about 8 minutes, but we'll run through what questions we do have on the line. We'll answer them to the best of our capability, and then we'll look and see. You're welcome to reach out to us if there's a question we didn't get answered and is urgent. If not, I would suggest that you reach out to tech support. So, Brad?
Hi, Robbie. Thanks for the great presentation. I do have several questions for you. The first question is just stating that there's a lot of great information in this presentation. Can you point people to where they could find additional documentation, whether it's in help files or maybe some guides? Yep.
So in the Help Center, we do have documentation of CAD represented parts as well as a little bit about assembly features. Unfortunately, I don't believe we have anything that gets into the level of detail of how it's accomplished in the structure. Maybe that's a good opportunity for us to go back and put kind of a common resource together for how dynamic visualization is working. I think that would be good. I think what I would encourage is probably CAD represented parts and the structure filter method have two phenomenal articles. If you search for CAD represented part inside of the PTC support site, then you should be able to bring up, and I believe that there's a YouTube video on how to configure and take advantage of that.
Perfect. The next question has to do with the image linked parts. The question is with 11.2, that now provides support for that within the dynamic product structure visualization. But the question is it doesn't appear to work when you use downstream bill of materials for MBOMs or process plans. Is that intended to be changed or enhanced in the future?
Absolutely. That's one of the top priorities we're looking at inside of Windchill 12. What we identified is, I should clarify, it's not just the image association. It's also assembly features and flexible positioning. All of those use cases, when you modify the downstream bill of material in such a way that there's not a clear relationship between the part owning the override and the result. So, this would be the assembly and the part that's affected. When you modify that in the downstream bill of material, it can't find that anymore. So we're putting an underlying infrastructure in place with Windchill 12, with the intent in Windchill 12 to release that. And again, that's future facing, but it is our intent to go ahead and put a generic infrastructure in place such that all of these capabilities will be able to visualize in the downstream bill of material correctly.
Perfect. All right, the next question has to do with family tables and having different representations. So the multi-state, for example, and the question reads, my company uses family tables for different views of the generic. There are times in the case of assemblies that wires, conduits, etc. are formed or bent. We associate the generic and the instance to the same WT part. Therefore, the generic is always shown in the visualization. Is there a way to choose which link is used for the visualization?
So that's what the functionality that we introduced with Windchill 11.2. So in Windchill 11.2, if you use a family table instance in an assembly, then it will recognize that you use that instance and not the generic, and it will then use the appropriate representation from the instance. That's with Windchill 11.2. If you're on something earlier than 11.2, you'll need to take a look at CAD represented parts or the part structure filter method to flag that parent assembly as something that needs to be CAD represented, so that way it can utilize the representation stored on the assembly instead of using the default generic in order to visualize that. So I'd say short term, if you're not going towards Windchill 11.2, use CAD represented parts or the part structure filter method. Longer term, you should be able to immediately see that transition without any effort whatsoever. It'll just show the right representation in Windchill 11.2 or later.
Yeah, I believe in this case they are using 11.1 M20, so it looks like in the next release they may have more capabilities. All right, let's see, we have a couple minutes left here. There are more questions in the queue. So the next question is relating to items, and do we need to have a one-to-one relationship between a part, in quotes, items, and the CAD file, or can you have, let's see, this is a two-part question, or is it possible to create one CAD file but use it to represent several parts? So it looks like a one-to-many, one CAD to many parts.
Yeah. Yep. So you can use one CAD model to many parts. I would say that there are some situations that is good and expected, and other situations where you need to be very careful. Because of the representable relationship that I talked about early in the presentation, where the owner relationship transfers the storage of the representation to the part. In that case, when there's a multi-owner where you have one CAD model but multiple parts, it still will pick and only vault that against one of them. You need to take a look at, there's a feature to call copy to described parts. In that event, there will be one part which is considered the primary owner relationship and the others become secondary. It will then copy that representation over to the secondary owner relationships where that will be stored. It's an area that we're looking to improve a little bit especially when it comes to use cases like color or material variants based on that, where you've got a single CAD design, but it needs to go to multiple parts. But that is a valid working practice. I would not say that, don't do that, but I would just say you need to be a little careful that there is some extra considerations that need to go into that.
Perfect. All right, one more question I have. I know we're running short on time. Which of the capabilities shown today are exclusively for Creo Parametric, and which capabilities discussed would potentially also work with SolidWorks?
So the features that are Creo Parametric specifically are the first thing that I demonstrated, which is assembly features, where there's overriding geometry that's owned at an assembly level, changing a part, and flexible positioning, which is where the assembly is changing the position of its grandchildren. Those are Creo specific. However, they're only Creo specific in the publishing of the content. The functionality in Windchill is generic. That means in future releases of Creo View, where the Creo View adapters are released, we do intend to enhance those for SolidWorks, for NX, for CATIA to flag those situations, in which case your existing Windchill systems would work. You would just need to have a later Creo View adapter version when we release that support for it.
All right.
Okay.
We do have more questions, Robbie, but I think we'll take those offline and respond given the time constraints of this webinar.
Perfect.
All right. Well, thank you, Robbie. Thank you, Brad. Great insights, and for all of your questions for all the attendees. Like Brad said, we'll take the rest of the questions offline. Robbie will respond to you. If folks have questions or they want to learn more, there's plenty of resources available. You can visit the PLM page on our support portal for technical documentation, or ptc.com PLM for white papers, customer stories, buyer's guides, and so on. If you'd like to get in touch with a PTC expert, you can contact your AE or click on the Contact Us from the PLM page on ptc.com. As a quick reminder, this session was recorded. Look for an email from PTC in the next week or so with a link to the webcast for on-demand viewing. Also, be on the lookout for future invites for other Tech Tip webcasts. Some upcoming deep dive topics will include Windchill REST services, Windchill flexible change management solutions, Windchill reporting for digital intelligence, and others. So a big thank you to our presenter, Robbie, and Brad, our Q&A moderator, and to you, our attendees, for participating in today's session. This will conclude our webcast, Configuration-Driven PLM Visualization. We hope you find this useful. Stay safe and stay healthy, everybody. Thank you.